How will space tech create a breathable Mars atmosphere? Have you ever wondered how we might transform the red planet into a place where humans can breathe freely? The journey to create a breathable atmosphere on Mars is filled with challenges, but space technology is paving the way. Let's break down how this can happen. First, we need to tackle the cold temperatures on Mars. The average surface temperature is around -80 degrees Fahrenheit. To warm the planet, scientists propose injecting engineered dust particles into the Martian atmosphere. These particles, made from the abundant Martian dust rich in iron and aluminum, could help trap heat. This method could potentially raise the temperature by over 50 degrees Fahrenheit within a few decades. As the planet warms, frozen carbon dioxide from the polar ice caps could be released, thickening the atmosphere and enhancing the greenhouse effect. This would create conditions more suitable for liquid water and life. Next, let's talk about atmospheric pressure. Currently, Mars has less than 1% of Earth's atmospheric pressure, making it impossible for humans to breathe without assistance. While warming the poles will release carbon dioxide, studies show that there is not enough accessible carbon dioxide on Mars to reach Earth-like pressure levels with our current technology. Therefore, we need to think outside the box. This could mean importing gases from other sources or developing methods to produce gases on Mars through chemical processes. Now, generating oxygen is essential for a breathable atmosphere. Mars' atmosphere is composed of about 96% carbon dioxide, with only trace amounts of oxygen. One promising technology is the Mars Oxygen in situ resource utilization experiment. This device, currently being tested on Mars rovers, converts carbon dioxide into oxygen using a process called electrolysis. If we can scale up this technology, it could produce breathable oxygen locally. Over time, combining oxygen production with atmospheric thickening could lead to a more habitable environment for future settlers. Finally, we must consider protecting the atmosphere from solar wind erosion. Mars lacks a global magnetic field, which means any atmosphere we create could be gradually stripped away by solar radiation. Space technology is exploring concepts like artificial magnetic shields to protect the atmosphere once it is established. In summary, creating a breathable atmosphere on Mars involves warming the planet, thickening the atmosphere, generating oxygen, and protecting it from solar wind. While these processes will take decades to centuries and requiring significant advancements, they representing the core strategies for making human colonization of Mars a reality. The future of Martian colonization is bright, and with continued innovation in space technology, we may one day breathe easy on the red planet.